Hello boys and girls, welcome to another Algebra 2 skills review video. This is for standard F-IF.6. Today we're going to calculate and interpret the average rate of change of a function. We're going to see this presented symbolically or as a table over a specified interval. And we're also going to estimate the rate of change from a graph. Okay, so let's start off with a table here. We're going to calculate the average rate of change over the interval from 2 to 10. So first of all, we need to note here that the average rate of change, this phrase right here, is just the concept of slope. Okay, so the average rate of change, that's the fancy way of saying it. That's what I'm going to stick with. But so you just need to know that this is just slope. Okay, so how do we calculate slope? Well, slope is your change in y over change in x, right? Change in y over your change in x. Right? Okay, so this is also, I'm going to write the slope formula, y2 minus y1 over x2 minus x1. So now I'm going to look at the question here again. I know that my interval is going from 2 to 10, so that's my x values, right? So x is starting at 2, so my output is -1 when x is 2. And I'm going to the point when x is 10, my output is 23. So I'm going to take those values and I'm going to substitute them into my equation that I wrote here, my y2 minus y1 equation. Okay, so I'm going to call this x1, y1, x2, y2, and I'm going to put in my values. So I'm going to have 23 minus -1, and that's going to be over 10 minus 2. So 23 minus -1, that's going to be 24. Over 10 minus 2 is 8. And I know that 24 divided by 8 is 3. And that's as simple as I can make it. That's my average rate of change. My average rate of change is 3. And if you notice, for every time x goes up 1, y is going to go up 3. So here, in my first jump, x goes from 2 to 4. That went up 2. My y value went up 6. So this went up 2, this went up 6. And that continues for all of these points, not just from 2 to 10. Okay, so that's how we calculate the average rate of change over an interval given the table. Let's look at another example. This time it's going to be encased in a word problem, and we're going to have the same idea here. We're going to calculate the average rate of change. Okay. So a marathon runner notices that at mile 5, her race time is 40 minutes. And at mile 9, her time is 72 minutes. So we're going to calculate her average rate of change, and we're going to use appropriate units this time. So that's going to be the addition that we get onto here. So if you notice the coloring that I used here, I really marked this out so that you can see the two different points that we have here. The first point that we have is that at mile 5, our runner has been going for 40 minutes, so there's our first point, 5, 40. And our second point is when she's at mile 9, she's been running for 72 minutes. So there's my x1, y1, and my x2, y2. So for my average rate of change, again, I'm going to write it as slope equals, and I'm going to write out my formula again. Y's over x's, right? And I'm just going to substitute in my points. So y2 is 72, y1 is 40, x2 is 9, and x1 is 5. So I have 72 minus 40 is going to be 32, and 9 minus 5 is going to be 4, and I know 32 divided by 4 is going to be 8. So that's the value for my average rate of change. I now need to look at my units here. Okay, so I'm going to look at what my units are for my numerator, and then that's divided by the units for my denominator. So my units for my numerator are minutes, right? 72 minutes, and we have 40 minutes, right? So my units in the numerator are going to be minutes divided by, well, what are the units for my denominator? Well, it's miles, isn't it? 5 miles, 9 miles. So I'm going to have 8 minutes per mile is this runner's pace. So there's my average rate of change with appropriate units. And that's how we did it. We just divided the units on top, stay on top, and the units in the denominator stay in the denominator. Okay, let's look at one more problem here, and this is going to be our last example. So in this example, we have a graph here, and I just have this line. I don't have any points whatsoever. We're just going to estimate what the average rate of change should be here. So, well, what do you notice about this line here, this green line that we have going on over here, right? What's this thing doing? Well, it's going down to the right. So when it's going down to the right, is the slope, is the average rate of change going to be positive or is it going to be negative? Well, it's going to be negative, right? So negative slope or negative rate of change. Okay, so in my multiple choice question over here, I can get rid of the half, I can get rid of the 2, and I can get rid of the 0. The question is this average rate of change negative a half or negative 2? Well, it's kind of a shallow rate of change, right? This line here it's pretty flat, right? If it was steeper, that'd be a different story, but it's pretty flat, right? So it's close to 0, and it's certainly a little less than 1. If it was negative 1, it'd be like at a 45-degree angle there, right? Okay, but it's kind of shallow there, so I'm going to have my final answer as negative 1/2 for my average rate of change here. So let's change this up a little bit. Let's say my slope is, I'm going to change this green line here, and let's say my slope looks something more like this. What would you estimate the average rate of change to be? Well, the slope is no longer negative, so I can get rid of this. Well, the slope is positive now, right? Okay, so I'm looking for a positive slope, and is it steep or is it shallow? Right? Is it bigger than 1 or is it less than 1? Well, it's certainly steeper than 1, right? So it can't be a half. Good timing there, huh? It's got to be something more like 2, right? Again, this is just an estimate. It's an approximation. If I had another answer up here that was 3 or 4, I wouldn't really be able to tell because I have no scale here. I really can't tell the difference between a slope of 2 and 3 in this instance. But certainly 2 is different than all the other ones here. Okay, last example here. What if we had the line looking like that? What would our slope be? Well, that's a flat line, right? There's no change in our output. So this is a slope of 0. Okay, so hopefully all this was beneficial. Hopefully that you have a little better understanding of how to calculate and interpret the average rate of change. Again, that's just the slope, right? Average rate of change. Fancy word for slope. So we calculated the average rate of change for a function. We did this symbolically using the last column with the runner, and we also saw a table over a specified interval, and we estimated the average rate of change from the graph, and we did that a couple times, didn't we? So hopefully you found this beneficial, and take care and have a great day.